Yes, now we come to this one. Writing chemical formula of compounds. Okay. Yes, how do we start with this? Okay, here you have to know that, we are going to use the simplest approach. Okay, you have to know that all the elements we saw, they have combining power. So you have to remember that we have them in groups. So you can say groups. And here you can say valences. So you have to know that group 1 have valence 1. Group 2 elements have valence 2. Group 3 elements have valence 3. Group 4 elements have valence 4. Now, group 5 elements have valence 8 minus 5, giving you 3. Group 6 elements have valence 8 minus 6, giving you 2. A group 7 elements have valence 8 minus 7, giving you 1. Group 8 elements have valence 8 minus 8, giving you 0. Now, I would like to tell you that these ones are positives. They are electropositive. They prefer to attain positive charge. You'll go deeper into that next time. Meanwhile, these ones starting from 5 onwards, they are negatives. They prefer to attain negative charge. And that is very, very important. So then we come to anions and radicals. Okay. These are very important also information of compounds. So you have to remember that for these ones, we can categorize them into those with valence 1, those with valence 2, and those with valence 3. So those with valence 1, we've just listed these, but there are more. All the group 7 elements are having valence 1, and I've just chosen 2. But you have to know that bromine and iodine are on this list of those anions with valence 1. I want you to know that what you call radicals are species which cannot exist on their own, but they only exist in compounds. So let us look at here. We know that fluorine is F, chlorine is Cl, hydroxide is OH, nitrate is NO3, nitrite is NO2, chlorate is ClO 3. Permanganate is MnO4 minus. Now I want you to know that all these ones are -1 because they have valence 1 and they will form the negative part of the compound. So for those anions and radicals with valence 2, we have oxide, which is going to be O, carbonate, which is a CO3, sulfate, which is SO4, sulfite, which is HO3, thiosulfate, which is S2O3, chromate, which is CrO4, sulfide, which is simply S, dichromate, which is CrO7. Now you have to know that these ones are valence 2, and so they are going to be -2, -2, -2, because they form the negative part of the compounds. Now, those with valence 3, we have phosphate, which is represented as PO4. So if it's valence 3, it's going to be 3 minus. Then another one is nitride, which is represented as simply N with a 3 minus. Then phosphide, which is simply P, but because it has valence 3, it's going to form the negative part of the compound. It is a 3 minus. Thank you. Now I need to remind you here before I close this page that hydrogen carbonate, hydrogen sulfate and sulfide, hydrogen phosphate, and other hydrogen compounds. The coming of hydrogen reduces the valence, the normal valence, by 1. So when you look at here, we know that carbonate is valence 2. But when it's hydrogen carbonate, it's going to be 2 minus 1, and you remain with the valence 1. Sulfate is valence 2, you have it there. But if it's hydrogen sulfate, hydrogen reduces it by 1 and becomes valence 1, because 2 minus 1 is 1. Phosphate is valence 3, like we know. But when you're talking about hydrogen phosphate, it's going to be 3 minus 1, which gives you valence 2. That must be known. Yeah. Now we have come to the climax of writing chemical formula of compounds. Okay, the first example we are having is this one. It is magnesium chloride. So what do we do? You must know the symbol for magnesium. And also you have to remember the valence. Magnesium is group 2, so it's valence 2. Next, you have to know the symbol for chloride, which is chlorine, and the valence is 1. Remember, it's group 7. So what is next is very important, that what you have as the valence of this one comes here, and what you have as the valence of this one comes here. Yeah, they become subscripts. But you have to know that if the subscript is 1, we do not write it. So this means that the compound you are going to get here is going to be magnesium. There is a 1 here, so we don't write it. So you say chloride, and the 2 has come there, so it's 2. Next is magnesium oxide. So how do you go about this? You have to know the symbol for magnesium, which is Mg, and its valence is 2. It is a group 2 element. Next, you have to know the symbol for oxide, which is oxygen, and is also valence 2. Now, what do you do? Now, what do you do when you have them the same? What you do is that they cross out. They don't appear. So, what will form is going to be MgO. Those similar ones cancelled out. Now, next is magnesium phosphate. How do you approach this? You have to know the symbol for magnesium, and this valence is 2 because it's a group 2 element. You have to know the symbol for phosphate, and this valence is 3. So what happens is that this becomes the subscript for this, and this one becomes the subscript for this. They exchange, giving you Mg, and it received 3, so 3, PO4, and it received 2. But you have to know something here, that this 2 is for the entire phosphate. How do we show that? By putting a bracket. The bracket is the evidence that the 2 is for the whole phosphate. And with that, I would like to thank you for your time. The channel is PSSB, Physical Sciences. Silver Bullet with me, Richard here. We urge you to subscribe, to comment, to like, to share. And we have also to remind you that Physical Sciences, Silver Bullet, specializes in Physical Sciences grade 12, 11 and 10, and Natural Sciences grade 8 and 9. We urge you to make use of our simplified playlist, where all the materials are easily accessible. For grade 10, we would advise you to go to playlist and click grade 10 Physical Sciences. All the materials will be exposed to you. We mean all because we are simply the best. Stick with us. You'll not regret. See you then. Bye bye.